sun radiation, the solar panels which may convert it into according to the changes only. There is no phenomena which make that the variable sunlight will maybe make as constant. Just the solar panels, what they can do, so how much intensity is there in the solar panel, simply they may convert it into electrical energy. If it is in high intensity is there, it may convert it into high. So it is low intensity, low. So there is no phenomena to make as a constant. And simply what we are getting from the solar panels, we are getting non-continuous and non-constant power. So then what we are going to do, so we are going to make that the non-continuous and non-constant DC power from the solar panel, which may makes as a continuous and constant DC power. ఓకేనా. సో మనం ఇప్పుడు ఏం చేయాలి, ఈ సోలార్ ప్యానల్స్ వచ్చి నాన్ కంటిన్యూస్ అండ్ నాన్ కాన్స్టెంట్ పవర్ని మేక్ యాజ్ కంటిన్యూస్ అండ్ కాన్స్టెంట్ పవర్. ఫర్ దట్ పర్పస్ వీఆర్ గోయింగ్ టు డూ వన్ మోర్ టెక్నిక్ దట్ ఈస్ కాల్డ్ యాజ్ కన్వర్షన్ ఆఫ్ దట్ generated DC power from the solar panel into fixed DC by using the bidirectional DC to DC converter. It is the BDC. Clear? So bidirectional DC to DC converter అంటాం. Okay, so what the bidirectional DC to DC converter they can do, so they can convert that the variable DC supply into fixed DC. Okay, and means the non-continuous into continuous, sorry, non-constant into constant power supply. But one more drawback is there, non-continuous into non-continuous into continuous power supply. That is impossible with the solar panel. Why? Because so if there is a changes will be observed on the atmospheric conditions that may influence the power generation through the solar panels. So మనకు ఫర్ ఎగ్జాంపుల్ త్రూఅవుట్ ద డే 24 hours తీసుకుంటే, సో ఇన్ దట్ 24 hours ఓన్లీ 12 hours పవర్ సోలార్ ఎనర్జీ ఈజ్ అవైలబుల్. రిమైనింగ్ 12 hours దట్ ఈస్ ఇన్ నైట్ టైమ్ దెర్ ఈస్ నో సోలార్ రేడియేషన్స్. ఓకేనా. సో కమింగ్ టు ద డే టైమ్ ఆల్సో, అట్ ఎర్లీ మార్నింగ్ అవర్స్ ఆర్ ఈవినింగ్ అవర్స్ ద సన్ ఇంటెన్సిటీ ఈజ్ వెరీ లో. So next one more condition, during the rainfall conditions or clouds moving conditions, the solar panels is under shadow condition. They are not generated electrical energy. Why? Because they can't absorb the sun radiation. So at that time period, the solar panels will not generate the electrical energy. Okay. So that is the non-continuous power generations. To make that non-continuous as a continuous power supply, we are taking the support of battery energy storage system, that is called as BES. What the BES they can do, if the solar panels will generate the sufficient electrical energy, there is no use of BES, there is no purpose. If it will be generated either excess power during the high solar intensity condition, so the excess power will be stored in the battery. How much will be needed for the load requirements, that will be taken from the solar panels and gives to the load requirement. The excess power we can store here. Okay, so here the operating voltage is different, battery operating voltage is different. So through this BDC, bidirectional DC to DC converter, we may convert that the solar generated operating voltage DC into battery required operating voltages. Okay, so if solar panel will generate that less power during the less intensity condition, how much deficiency is there for the load requirements, that power we can take from the battery. So during that condition, battery is in discharging mode. Here operating voltage is different, battery operating voltage is different. What we are going to do, the same BDC will make that the battery operating voltage into this high voltage, high DC voltage, that is nothing but solar panel DC voltage. So that is the function of bidirectional DC to DC converter. So what the BES they can do, they can make that non-continuous into constant power. What the BDC they can do, so the BDC will make that the variable DC supply into fixed DC, that is at BDC we are getting that constant DC power supply. So once we are getting that constant DC, by using that with the help of voltage source converter, we may convert the DC voltage into 3-phase AC, that is given to the load requirements. Okay, it is the total function of your project. Clear? Here how many types of conversions we are doing, we are using two type of converters. One is called as voltage source converter, another one is called as bidirectional DC to DC converter. Clear. Coming to the DEGS, so diesel energy storage system or diesel energy generating set antam. Okay, na? So the diesel energy storage generator set will not generate the power continuously. Why? Because compared to the solar power generation, here the power generation cost is more. Okay, na? So for that purpose, what is our aim? We are going to satisfy the load requirements continuously through the power generated from the solar panel and with the help of battery. That is our main motto, to supply the electrical energy to the load requirements. If it is impossible to supply to satisfy the load requirements through PV and battery energy storage system, at that situation only we can operate the diesel generating set. Okay na? Why? Because so manam ikkada free of cost we are generating the electrical energy through PV. But coming to the diesel energy generating set, here we are spending some amount on fuel, that is nothing but diesel. So it is the costly power generation compared to the all power generations. So diesel engine generated set will have the more cost. We spend more amount on fuel, diesel. So then that generation cost also more. So for that purpose, so what we are going to do, we can make that the load requirement satisfaction through battery and solar power generations. If these two sources are not possible to satisfy the load requirements, then we take the help from the DEGS. So it is our major application. So major application of your project. So coming to the flow chart, here it is the flow chart for incremental conduction MPPT method. So incremental conduction MPPT is nothing but maximum power point tracking scheme. So this is the control technique we are using to make that gate signals, for the generation of gate signals or pulse duty ratio for the BDC, bidirectional DC to DC converter. Here we are using that incremental conduction MPPT technique. So for VSC, voltage source converter principle, so this is the normal DC to DC converter. మనం ఆల్రెడీ ఇందాక చూసాం, నార్మల్ బూస్ట్ కన్వర్టర్. So it is the control technique which we are using for the voltage source converter. So whatever it may be the voltage source converter we are using in your project. So for the operation of the voltage source converter, they need the control signals, that is nothing but gate signals. So those gate signals we are generating through this control technique. So these are the gate signals: S1, S2, S3, S4, S5 and S6. Total 6 signals and 2 more, S7 and S8 for neutral terminal. So here we are taking that so 4 bridge. So 1 2 3 4. So 1 2 3 4. So why? Because here we are taking that 4 terminals, RYB and neutral. RYB and neutral. Okay, so for that 4 terminals are there. So each terminal contains so 2 switches. One is for forward bias, another one is for reverse bias. So upper limb and lower limb and up. So for that purpose they need total 8 gate signals. These gate signals are there. So we are generating through this control algorithm. Is it clear? Babu, are you following?